Okay guys, so we're going to look at how we can draw like a rough sketch of the derivative or slope graph when we're given a function. So what we want to look for are places where the slope is 0 or really close to 0, places where the slope is negative or positive. So let's look at this. It looks like the slope is really close to 0 at the end, right? A slope of 0 on a line, it would look something like this. On a curve, it would look something like this. The slope is 0. The horizontal tangent line, right, you can see it there, has a slope of 0. So you can see that towards the end, it looks like we're leveling off to a slope of 0. At the beginning, you can look and see that the slope is negative. The way that you know the slope is negative is that the function values are decreasing. So it looks like we start off with kind of a steep negative slope, right? Like a line like this would have a steep slope. A line like this would have a slope of almost 0. So we start out with a steep slope, like a negative number that's big in absolute value. And then we level off to having a slope of 0. So here's what our slope graph would look like, something like that. Okay, for 2, let's see where the slope is 0. Looks like the slope is 0 at 0, when x is 0. And also, it looks like it's pretty close to 0 when x is 2 and when x is negative 2. So we're going to put a dot at 0. And let's look at what's happening to the left. So we can see that the slope is positive because the function values are getting bigger. So we have a slope that's close to 0, then like positive, then levels off again to having a slope of 0 right here. On the right-hand side of 0, you can see the slope is negative. The y values are decreasing. And then they level off, the function levels off to having a slope of 0. So you have a negative slope that levels off again towards 0. Okay, let's look down at 3. Scroll down. Okay, so for 3, we can see that we have a slope of 0 when x is 0. So let's put a dot at 0. To the left, we can see that the slope is negative. We start out with a really steep negative slope, and then we level off towards having a slope of 0. So it's like a small negative number gets closer to 0. Then on the right, the slope is close to 0, and then it gets more and more positive. Okay, so now let's look down at number 4. So for 4, again, it looks like the slope isn't exactly 0 anywhere, but it looks like it's getting close to 0 at the end. So at the beginning, I don't know if you can see it this well, but it looks like we have a really steep slope at the beginning. Then we level off closer to having a slope of 0. For the whole time, the slope is positive because the y values are increasing. So to draw our derivative graph, we start out with like a really big positive number, and the slope values get closer to 0 at the end. Okay, so now let's jump down to number 10, and we're basically going to be doing the reverse. We're going to be given a slope graph, and we have to draw one possible function graph. So now, it's possible that a lot of different functions have the same slopes. We could have the graph shifted up or down, and I'll show you more about what I mean with that. So let's start by seeing where the slope is 0. So the slope is 0 pretty close to negative 1. And the slope is 0 pretty close to positive 4. Okay, so at the beginning, the slope is positive. The slope is maybe positive 8, then positive 7, then positive 6. So that means our function values are getting bigger. They're increasing. So here's what we have. A positive slope, the y's are getting bigger, and then we level off to having a slope of 0. Now, in between about negative 1 and close to 4, the slope values are negative. Well, that means that our function values are decreasing for that whole time until we get to about 3.9, where they get to having a slope of 0. So we decrease, and then we start to turn around and level off and have a slope of about 0. I'm sorry, we should have a slope. I try to erase this. It doesn't look like I did the best job there. We keep decreasing, and then we level off at the end with close to 3.9. Then, after that, the slope is positive. That means our y values are increasing. Now, we didn't know any y values on our graph. All we knew was the shape of the graph. So it's possible that your graph could look like this, Or like this, you could shift the graph anywhere, up or down. Okay, let's try number 11 here. So for 11, we have a constant slope on a few different intervals. So at the beginning, we can see that the slope is 2. So we want to draw like a little line segment that has a slope of positive 2. So that is the case, it looks like, from before -4 all the way up to 0. So let's start here, and we're going to count up 2 over 1, and then up 2 over 1. So whatever, this is just a rough sketch. So we should have like a little line, or it's actually an array, with a slope of 2. Then we can see that the slope is -2 between 0 and 2. So we count over 1, down 2, over 1, down 2. And that only works until x is 2. Then we have a line segment that has a slope of, let's see, positive 2. So we count over 1, up 2, over 1, up 2. The y's on this graph are the actual slope values. All right, let's try to do 12. So for 12, we look and see where the slope, oh, sorry, hold on. Okay, so I'm sorry about that. So for 12, we look and see again where the slope is 0. So we can see that the slope is 0 at about, what, like -0.5, and at very close to positive 2. So before that, the slope is positive. So that means our function values are increasing and then leveling off to a slope of about 0. Then, between like -0.5 and about 2, the slope is negative. Well, that means our function values are decreasing until we get to about 2, where they level off to a slope of 0. Okay, then the slope is positive. So that means our function values are increasing.